Welcome to Math Proofs. My name is Adiyoja, and today we're going to be proving why the sum of any three angles in a triangle is 180. And that is to say that if we have a triangle and I label the three interior angles as A, B, and C, that A plus B plus C is equal to 180 degrees. This is something we learn in our basic geometry class. We are told to memorize it, but we may not know why it exactly is true. And in order to fully understand why it is true, we first have to talk about alternate interior angles. So let's get right to it. So let's first talk about alternate interior angles. What I've drawn here is a black line that is supposed to be horizontal. So I'll label this line with an H for horizontal. And then we have a red line that comes in at an angle to this black line. I'm going to define this angle over here as being A. And the first question I'm going to ask you in our discussion is, what is this angle over here? Well, hopefully you can see that this angle will also be A. And the reason for that is very straightforward. The way that this red line is defined is that it is always A degrees away from this horizontal line. So no matter which point I take over here on the red line, let's say from this point down to this point, the angle measure over here is also A degrees. So no matter where I go on this red line, it always has to be A degrees away from the horizontal line. Now I can go forward, going this way, or I can go backwards, going this way. So going backwards this way between here and here, as the red line is defined, it must have an angle of A degrees. Now this is not the alternate interior angle theorem, but it will help us get to it. So let me erase some stuff, and now let's go on to our second question. So now we agree that these two angles here are equal, they're both A, but let's say I draw another horizontal line down here. Now I could say that these two lines are parallel because they're both horizontal. Now I'm going to take this second horizontal line and I'm going to shift it up. And let's say I plop it down right there. We have lost some of our red line, so let me redraw that red line. But now I'm going to ask you this. What is this angle over here? Well, you guessed it, it would also be angle A. And you may be asking, why is that? Well, remember that both of these lines are horizontal. And the red line is defined as being a line that is A degrees away from a horizontal line. It doesn't matter that this horizontal line is above this horizontal line. The definition of the red line is I'm always going to be A degrees above a black horizontal line. Now, using similar logic that we used down here, we can state that this angle over here will also be A. And that is what the ulterior angle theorem states. It states that if you have two parallel lines, in this case they're horizontal, but they could be any two lines as long as they're parallel, and you have one line passing through both of them, then the two interior angles, A over here and A over here, will be equal. Now let's move on to triangles. So now we're back to the page with the triangle. I've changed a few things just for the proof. I've labeled A in red and C in blue, B is stayed in black, and I've added two black horizontal lines above and below. The below line is intersecting with the bottom side of the triangle, and the top line is also touching this point here on the triangle. So let's now use the alternate interior angle theorem to go about with our proof. So the alternate interior angle theorem stated that if I have an interior angle over here and an interior angle over here, these two angles will be equal. So if this angle over here is A, this angle over here will be A. And if some of you are a little confused because in the proof on the ulterior angles we had a line that extended out this way, let me draw it in black. we had a line that was extending out like this. I'll briefly show you why this works again. So we know that this angle over here is A, so we know that this angle over here will be A, and therefore we know that this angle over here will be A. So just in case you were a little confused that in the last frame we had a little longer lines, this maybe should clarify things up for you. But anyways, we know that this angle over here will be A. And we can use a similar logic for C. This is an interior angle, and this is an interior angle. So if this angle over here is C, this angle over here will also be C. And you can use the same logic with this extended line to prove that as well. Now let's look up here to what we have above. I'm going to erase some of this extra stuff just to make it easier. So let's look right here. We have angle A, angle B, angle C. These are all the three angles that are inside of a triangle. And we see that if we add up all these angles, we're able to go from one side of the line all the way over to the other side of the line. And for those of you who know your geometry, you know that whenever you go from one side of the line to another side of the line, that is 180 degrees. So therefore, as a result, angle A plus angle B plus angle C must equal 180 degrees. And hopefully you can see intuitively that as we change this triangle any which way, this angle over here, this interior angle will always be A, this interior angle will always be C, and as a result, when you add them up, you will get 180 degrees as your total. This has been a Math Proofs video. My name is Adi Oja. Thank you for watching.